Find an equation for the normal to each curve at the point on the curve with the given x coordinate. And we need to give our answer in that form. So we want to differentiate to get our gradient function. Substitute the x coordinate in to get the gradient of the tangent at that point. Then do negative reciprocal and do y equals mx plus c. So y equals x squared times the 2x minus 3, the 2 minus x to the power 3. We're going to have to use product rule. So u is x squared, v is 2 minus x cubed. So u dash, differentiating the x squared, I get 2x. V dash, so differentiating the 2 minus x cubed. Well, we're going to have to use the chain rule on this because we've got 2 minus x inside the cubed function. So we'll differentiate the cubed function first to get 3. So times by 3, take 1 away from the power. And then we have to multiply this by the derivative of the inside. The derivative of 2 minus x is just minus 1. And that's going to simplify. The 3 times the minus 1 is just going to be minus 3. Right, applying the product rule then. U dash times V plus V dash times U. So this is my gradient function. If I now substitute 1 in here, 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 and here, so I get 2 times 1 is 2, 2 minus 1 is 1, 3 times 1 squared is 3, the 2 minus 1 is 1, so we end up with 2 minus 3, which is minus 1. So the gradient of my tangent at that point is minus 1, which means that the gradient of the normal will be the negative reciprocal of that. So I'm going to take that minus 1 and make it positive, and the reciprocal of 1 is just 1. So the gradient of my normal is 1. So I can say y equals 1x plus c. I now want to substitute a coordinate in here. I know about when x is equal to 1. Let's substitute 1 into this original function to work out what y is. And I see that y is also 1. Which tells me that c is going to be 0. And therefore I can say just y equals x, all in the form that it wants me to give this. I want to take y away from both sides to get x minus y is equal to 0. Second question. Again, we've got a product of two functions. We've got the x being multiplied by the ln 3x minus 5. So product rule. X can be my u function. Ln of 3x minus 5 is going to be my v function. Differentiating x, I get 1. Now, to differentiate the ln 3x minus 5, I need to be careful with this because I've got the 3x minus 5 that is inside the ln function. So chain rule. Let's differentiate the outside function first. The 1 over the ln will differentiate to be 1 over. And then I have to multiply this by the derivative of the inside. The derivative of 3x minus 5 is 3. And then the 1 times the 3 is just 3. Applying the product rule now then. So u dash times v plus v dash times u. So that's my gradient function. If I substitute my x coordinate of 2 into that, that's going to tell me the gradient of the curve at that point. So let's substitute 2 in here, and here, and here. So 3 times 2 minus 5 is 1. 3 times 2 is 6, over 6 minus 5, which is 1. ln 1 is just 0, and 6 over 1 is just 6. So that's the gradient of the curve at that point, which means the gradient of my normal will be the negative reciprocal, so minus 1/6. I'm now going to do y equals mx plus c. I want to know what the y coordinate is when x is 2, so if I substitute 2 in here and here, well, the 3 times 2 minus 5 is 1, and ln 1 is just 0. So it's going through the point 0, 2. Which means that c is 1/3. So I can substitute that here. And now, just to simplify my answer, I'm going to multiply everything through by 6. And then add x to both sides, and subtract 2 from both sides, and that's my answer.